This is for U12 specialists. It comes out of complex numbers. How do I sketch the region or sketch the complex numbers that satisfy these conditions? Okay, so in part B, the modulus of z plus 3 is less than 3. Well, I know the modulus of z plus 3 equals 3 is a circle. It's centred at negative 3, 0. And has a radius of 3, so that is on the circle. If I'm actually wanting all of the complex numbers that satisfy this, then all of the complex numbers are on this circle, because all of them, for example this one here, Z1, has a radius of 3, which is what that says. And this one here also has a magnitude of 3, and this one here also has a magnitude of 3. So that's what that means. If I'm wanting it less than 3, then I'm wanting all the ones in here, because all of them have magnitudes away from the centre of less than 3. So I'm wanting everything inside that circle, but I don't want to include the circle. So I've got to have a dotted line around the circle, because that would equal 3. So this is the region that I want. In part 2, I'm looking for all of the complex numbers that satisfy this and this. So here is the circle that is greater than 1. The modulus of z, therefore its centre is at 0, 0, and it's greater than 1, and it needs to be on this line. So I'm looking for all of the complex numbers along there and along there. It has to be on this line, and it has to have a radius or magnitude bigger than 1. So I'm looking for that, and I'm looking for that. How would I find that point there? Well, I need to have x squared plus y squared equals 1, and y equals minus 2x. So x squared plus minus 2x squared equals 1, 5x squared equals 1, x equals root 5 on 5. So root 5 on 5, and y is minus 2. So minus 2 root 5 on 5, and this point here would be minus root 5 on 5, and positive 2 root 5 on 5. And that's what the other one's going to look like.